Okay, so you're filling out this notes page, and you should be able to fill a lot of it out all on your own from the stuff that we've already discussed in class. What is the parent function of an absolute value? Well, it's just y equals absolute value of x. Okay, so that's the parent function. Or we could write it f of x equals absolute value of x. Okay, so when we do the following part in number 2, we're just going to look at, is it the input, output, what's being changed, and how is it being changed. So A, we just see that the input is changing, so that's a left or a right slide, and since it's been changing by subtracting 5, it's actually going to go 5 units to the right. So it's going to go right 5 units. Okay, so B, we notice it's the output that's changed, and we're adding 9 to the output, so it's going to go up by 9 units. C, we see that the whole thing has been negated, so we've taken the negative of the output, so it has a reflection across the x-axis, so it's reflected across the x-axis, and so it's going to be upside down. On D, we notice that, oh my goodness, we have a multiplier of 3, which means that we've been stretched by 3, and you haven't learned about that yet in class, so that's something that you need to note. So it's been stretched by 3 along the y-axis, and then it's also gone down 2 on the y-axis because the output has changed by -2. All right, on E, you'll notice that we have a multiplier of 1/4. And whenever we have a multiplier of something less than 1 on the output, then it actually is a vertical compression. Whereas up here on D, we had a vertical stretch because we multiplied it by greater than 1. So on E, we have a vertical compression. And you'll also notice that we have a change in our input. We added 6, so that means we're going to go to the left by 6. Okay, so that's what changed there. So we won't go to the left 6 units. Okay, so now on F, oh my goodness, we have lots of things going on here. So F, we reflected across the x-axis, and on the x, we reflected it on the x-axis, that's the negative out front, so that means it turns upside down. We also have a change in the input, so the input changed by +7, which means that we're going to move to the left by 7. And we also had the output changed by -2, which means we're going to go down by 2. Okay, so we have lots of things going on in F. Okay, so all of that stuff, or most of that stuff, we've talked about in class, and so you should be able to clearly see those particular translations. This statement here in the middle, the horizontal and vertical shifts, help describe the location of the vertex, and that's exactly what we're dealing with. We're trying to find the location of the vertex so that we can clearly see where it's going to start, and then from there everything draws the same as the parent function. Well, one of the things that we want to note is the vertical form, the vertex form, and so in the vertex form of an absolute value function, that is written f of x equals a, so some multiplier, times x minus h, which is the change in the input, plus k, which is the change of the output. So from this form of the vertex form, we're able to note that the vertex ends up being h, k. And we'll also notice that the slope on the right side is the same thing as a, and the slope on the left side is actually -a. So we'll go through some of these examples to see how all of that vertex form actually works. So here on example 1, I've written out the vertex form down here so that we can see it readily. So when we look at this, we notice that there's A is 1. Okay, so we don't have to worry too much about A because we don't have a stretch or compression. One just leaves it alone. Okay, so we have an H. Notice the H is going to be 2. Okay, so H equals 2. K, we have a positive K here, but this is a negative 4, so our K is actually equal to negative 4. So now we know our vertex. Our vertex is 2 comma negative 4. So 2 comma negative 4 puts a vertex right here, and we know that the slope on the right side is going to be a positive 1, so we're just going to rise 1, run 1, rise 1, run 1, rise 1, run 1, and we get that slope. And on the left side, it's just a negative slope, and so it ends up being in that direction. And there's the graph of that particular absolute value problem. Okay, again, I've written the vertex form so that we can see that. In this case, we have an A equals 3. So that means we're going to have a stretch, a vertical stretch. We also have our H, because we don't have a negative here, we can change that to x minus a negative 5, right? Because minus and minus together gives us a plus. So in this case, our H is going to be negative 5. And we don't have a K, so that means K equals 0. Okay, so there's no change in the output there except for the vertical stretch. There is a change on the input. We did x plus 5, so that means we're going to go to the left by 5. So we end up with our vertex here, but now we have this vertical stretch. So that means that we're going to rise 3 and then run 1. Rise 3 and then run 1. And we'll do the same thing on the other side, rise 3 and then run 1, remembering too that we have a positive and a negative. And you'll notice now that we've stretched that graph up the x-axis. Because if we had graphed 1 as being the value of A, it would have looked like this blue line, okay? But because we're now multiplying it by 3, we stretch it up the y-axis. So for every change in x, we have 3 changes in y. That's what that stands for, because remember, slope is the change in y divided by the change in x. And since y has changed 3 times for every 1 change in x, we have to rise more than we run, which gives us that vertical stretch.